Hello everyone, welcome to your channel Data Science Studio, and today we are going to start with day 9 of statistics for data science. So let's get started. So in today's session we are going to discuss three important probability distribution. One is binomial distribution, Poisson distribution and normal distribution. So binomial distribution, it is a probability distribution for a discrete random variable and that can take only two outcomes. So a process in which each trial has only two possible outcomes and the probability of each outcome is fixed. For example, if you are tossing a coin, so if you are tossing a coin, it can get head or tail and the probability of both the cases is 0.5. So let's understand this binomial probability distribution with an example. So let's say that we have three coins and we are tossing three coins, and suppose that we are interested to know the probability of two heads. So when we are tossing three coins, we want to know in how many ways we can get two heads. So we can get HHT or HTH or THH. Now let's say that the probability of success, which is probability of getting a head, is P and probability of not getting a head is Q or 1 minus P. So here with the multiplication theorem, my probability of getting two heads will be PPQ, and then here it will be PQP, and here it will be QPP. So if I add all these probabilities, that will be the probability of getting two heads. So this will become P square Q. So this P square Q plus P square Q plus P square Q. So total it will become 3P square Q. So the probability of getting two heads in a three coin toss is probability of two heads is equal to 3P square Q. And in case of binomial formula, the formula will become, for a random variable x, the probability of R success. R success means here the random variable is, I am tossing a three coins. So my x value will be 3 and R success is, out of three coins I want to get two heads. So probability of x equal to R success will be NCR P की power R Q की power N minus R. Now put this example in the equation. So it will become 3C2 P की power 2 Q की power 3 minus 2. So this will become 3C2. If you will solve 3C2, this will be 3P square Q. So this is the formula for binomial theorem. Now there are some characteristics of binomial theorem. So first characteristic which we have seen, that there are only two possible outcomes and both the outcomes are mutually exclusive and collectively exhaustive, which means that the probability of one toss of a coin does not affect the second toss of a coin, and the random experiment is performed for a fixed and finite number of times. Fixed and finite number of times means that I am going to toss three coins. So this is fixed and finite number of times, which is n observations. So this is the observation. And each trial generates either a success denoted by P or a failure denoted by Q. So my success is P and my failure is getting a tail, which is Q. And since the outcomes are mutually exclusive, the outcome of any trial is not affected by the outcome of any other trial. And all the observations are independent of each other. For example, these three coins, they are independent of each other. And if P is the probability of success, then 1 minus P is equal to Q. So Q equal to 1 minus P is the probability of failure. So this is from the perspective of binomial theorem. And there are, for every distribution, we will have mean and standard deviation. So for binomial distribution, the mean is mu is equal to NP, where N is the number of observations and P is the probability of success, and standard deviation is sigma is equal to under root NPQ, like this. So now you should be very clear with how to implement binomial theorem. Now let's solve the example. So let's say that the incidence of a disease, it could be a certain disease, such that on an average 20% of the workers suffer from it. If 10 workers are selected at random, find the probability that exactly 2 workers suffer from the disease. So what is the probability of success that a worker suffers from disease? So probability will be, P will be 1 by 5 because 20%, and Q will be 4 by 5, which is 80%. So probability that a worker suffers is 1 by 5, probability that he does not suffer is 4 by 5. So exactly 2 workers, so we have to get exactly 2 success. So probability of X equal to 2, which means 10C2 1 by 5 की power 2 and 4 by 5 की power 8. So if you solve this, it will become 10C2 4 की power 8 divided by 5 की power 10. If you further solve it, the probability will be 0.302, which is 30.2%. So there is a 30.2% probability that if 10 workers are selected at random, at least 2 workers are, exactly 2 workers suffer from the disease. Now, not more than 2 workers suffer from the disease. So not more than 2 workers from the disease will be, so we will select that. So not more than 2 workers, so it will be probability of X equal to 0 plus probability of X equal to 1 plus probability of X equal to, so not more than 2 means it is less than equal to 2. So this is easy, just put the formula 10C0 1 by 5 की power 0, 4 by 5 की power 10, and then we have 10C1 1 by 5 की power 1 and 4 by 5 की power 9 plus 10C2 1 by 5 की power 2 plus into 4 by 5 की power 8. So if you solve all this, you will get 0.678. So there is a 67.8% probability that not more than 2 workers suffer from the disease if 10 workers are selected at random. The next question is, the probability that a college student will graduate is 0.4. So again, probability of success is 0.4, probability of failure is 0.6. Determine the probability that out of 5 students, none, 1 and at least 1 will graduate. So what is the probability that none will graduate? So probability of X equal to no graduate is equal to 5C0, which means the probability of 0.4 will be 0 into 0.6 की power 5. If you solve all this, it will be 0.077. So there is a 7.7% probability that if 5 students are selected at random, none of them will pass. And then probability of x equal to 1, that at least one student, so in the second one will graduate, only one will graduate. So probability of x equal to 1 will be 5c1 0.4 power 1 0.6 की power 4. If we solve it, it will be 0.2592. So there is a 25.92% probability that one student will pass, and at least one will graduate. So which means that one or more than one. So at least one will be probability of x greater than equal to 1 is equal to 1 minus probability of x equal to 0. So at least one will graduate. So if we subtract the probability of x equal to 0 from 1, we will get probability of x greater than equal to 1. So this will be 1 minus, we have already calculated this probability of x equal to 0, 1 minus 0.077, which is 0.9223. So there is a 90.223% probability that at least one student will graduate if 5 students are selected at random. So this is from the binomial distribution perspective, and I think you should be very clear that how to implement binomial distribution. What is binomial distribution? Next distribution is called as Poisson distribution. So it is a probability distribution that measures the number of occurrence of a, again, discrete random variable in a time interval. So in a specific time interval, it will calculate the probability, and where the average number of occurrence of the outcome is known or can be determined. So Poisson distribution occurs in those situations where there are very few success. So where there are few success against a large number of failures, or against a small number of failures against a large number of success, and has single independent events, and here also the events are mutually exclusive. Now let's say that the Poisson distribution can be given as probability of x equal to r success equal to lambda की power r e की power minus lambda divided by r factorial. So here also we have mean. So mean mu is equal to lambda is equal to np, and you have standard deviation. So here you have a standard deviation as under root np. So if the probability p of occurrence of an outcome of interest r in each trial is very small, so that's what we have discussed. In Poisson distribution, the probability of occurrence of an event is very small compared to the number of events. So let's see that with an example. So a manufacturer who produces medicine bottles find that 0.1% of the bottles are defective, and the bottles are packed in boxes containing 500 bottles. So you are aware of the average, and a drug manufacturer buys 100 boxes from the producer of bottles. Using Poisson distribution, find how many boxes will contain no defectives or at least 2 defectives. So first, in case of no defective, so my probability of success is 0.1 and my value of n is 500. So lambda will be lambda equal to np is equal to 500 into 0.001, which will be equal to 0.5. This is my lambda. Now my probability of x equal to 0 means no defective, which will be lambda की power r e की power minus lambda divided by r factorial. So this is lambda की power 0 will be 1, r factorial will be 1, so this will become e की power minus lambda is equal to e की power minus 0.5. So this is the exponential. If you see the exponential value of minus 0.5, it will be 0.6065. So there is a 60.65% probability that a drug manufacturer, if buys 100 boxes from the producer of bottles, there will be no defectives. And then what is the probability that at least 2 defectives? So this will be, if you have to find probability of x equal to 2, then you can do 1 minus probability of x is less than equal to 1, and this could be 1 minus probability of x equal to 0 plus probability of x equal to 1, like this. And then finally put the values. So probability of x equal to 0 e की power minus lambda, and probability of x equal to 1 will be lambda into e की power minus lambda. So if we solve all this, it will be 0.09025, which is equal to 9.025%. So now 9.205% is the probability that at least 2 defectives will be there. But how many defectives? So you multiply it with, you have 100 boxes, and each box there is a probability that 9.025% that at least 2 will be defectives. So it will be 9.025 is equal to 10 boxes. So there will be at least 10 boxes where at least there will be 2 defective bottles. So this is how you have to solve the Poisson probability distribution. So here also you have 2 outcomes, which is a discrete outcome, a success and a failure, but here it is in a defined time interval, and average number of occurrence of the outcome is known. So here you know the average number of outcomes of the bottles which are defective. So here the average will be, bottles are packed in box containing 500 bottles, so you are able to calculate average as lambda equal to NP. Now next is, we are going to talk about very important distribution, which is normal distribution. So normal distribution is a continuous probability distribution in which the curve is bell shaped and having a single peak. The mean of the distribution lies at the center and all the mean, median and mode are equal. The curve is symmetrical around a vertical line at the mean. So this is your normal distribution. This is a normal distribution. This is somewhere over here will be mean. So in this case, mean is equal to median is equal to mode. And most of the natural phenomenon in our nature also follows normal distribution. For example, height, weight, everything follows a normal distribution. So nature follows a predictable pattern in which most of the numerical values of a random variable are spread around the center, and greater the distance a numerical value has from the center, the fewer numerical value have that specific value. So as we move away from the center, the distance from the mean will increase. So in case of normal distribution, it is represented by the formula f of x is equal to 1 upon sigma under root 2 pi e की power minus 1 by 2 x minus mu divided by sigma. This whole square. So x is the random variable, mu is the mean, sigma is the standard deviation. So if a random variable x follows normal distribution with mean mu and standard deviation sigma, then we can express it as x follows a normal distribution with mean mu. So this normal distribution also followed what we studied in our earlier discussions is empirical rule. So we'll discuss about that as well. Now if the value of sigma is large, if the value of standard deviation is large, it reduces the height of the curve. So there can be another curve like this. So here this is sigma 1 and this is a sigma 2. So in this case sigma 2 is greater than sigma 1. So large value of sigma reduce the height of the curve and increase the spread. So this is spread. Small values of sigma increase the height of the curve and reduce the spread. And the area under the curve, represents the probabilities for the random variable x, and that area under the curve will always be equal to 1. The area under the curve will be always equal to 1. And there is a concept called as standard normal distribution. So standard normal distribution is similar to a normal distribution, but it is standardized where mean is equal to 0 and standard deviation is equal to 1. So here it will be same as normal distribution. And here your mu is equal to 0 and standard deviation will be 1, sigma equal to 1. So in this random variable, in case of standard normal distribution, random variable x is standardized by expressing its values as the number of standard deviation it lies to the either left side or right side of the mean. And the standardized normal random variable is called as z statistics. So z is equal to x minus mu upon sigma. So a z score actually measures the number of standard deviations that a random variable x is from the mean. And it is a normal probability distribution with mean equal to 0 and standard deviation equal to 1. So there are some rules for this. So within one standard deviation, this is empirical rule. So within one standard deviation, this is 1 sigma minus 1 sigma, this is 1 sigma. Within one standard deviation, 68.26, there is a 68.26 probability that the random variable x will lie. Within two standard deviation from the mean on either sides, there is a 95.44% probability that the random variable will lie. And within three standard deviation, there is a 99.74% probability that the random variable will lie within this region. That is the rule, empirical rule for standard normal distribution. Now let's see an example. So in a normal distribution, 31% of the items are under 45 and 8% are over 64. Find the mean and standard deviation of the distribution. So let's plot the normal curve. So here your mean is mu. So here your mean is mu and this value is 45. Let's say this value is 45. So under 45, 31% of the, so below 45 this is 31%. And now this left side is 50%. So what is this area? This area is 19%. Again your 64% of the 8% of the items lie above 64. So this is 64. So this is 8%. So what this will be? This will be 42%. So now one equation will be, we know that z is equal to x minus mu upon sigma. So we have to find the mean and the standard deviation. So one equation we will get is, so we have to find the z value where the area is 31%, because at that value of z we have the random variable value as x. So this will become 45 minus mu divided by sigma. And what is the value of z where the area is 31% on the left side? So for that you have to do the, for that we have to do the, see the normal distribution. So this is the curve, this is the z table. So in z table we have to find that value which is covering the 30% on the left side, which is minus 0.5. So minus is the left side and positive z table is on the right side of the mean. So here z value is minus 0.3084. So there z value will be minus 0.5. So this will be, first equation will be minus mu plus 0.5 sigma is equal to minus 45. This is my first equation. Similarly, I will get a second equation which is z is equal to 64 minus mu divided by sigma. So z value where the area under the curve is 8% will be 1.4. 1.4 is equal to 64 minus mu upon sigma. If you solve this, it will be minus mu minus 1.4 sigma is equal to minus 64. This is the second equation. So if you solve both the equations, you will get mu is equal to 50, sigma is equal to 10. So your mu will be 50 and sigma is equal to 10. So if you see that this particular 45 lies within 1 standard deviation and this 64 lies within 2 standard deviation. So that's how you have to solve the normal distribution questions. Now we'll see one more example. Let's say that a wholesale distributor of fertilizer products finds that the annual demand for one type of fertilizer is normally distributed with a mean of 120 tons and a standard deviation of 16 tons. So very easy. Again you plot the curve. So your mean is 120. So your value of z is equal to x minus 120 divided by 16. So here we have to find that if he orders only once a year, what should be the ordered, what quantity should be ordered. So we have to find the value of x to ensure that there is only a 5% chance of running short. So we have to find this 5%. So if you have to find this 5% of short, this area will be 0.45. Now we'll put the values. So z value for 0.45 will be 1.64 because we have to cover the this area of the portion. So 1.64 is equal to x minus 120 divided by 16. So x will be 120 plus 1.64 into 16. So the quantity will be 146.24 tons. So the x value is 146.24 tons, where there is only 5% chance of running short. So if you have to find the z value will be 1.64. We'll see that at 1.64 what is the area on the right side. So this is 1.6 and 4. So which is, it will cover the 95% of the area, which we have seen over here. Why it is showing 95%? Because this 50% is also added. This 50% is also added. So 50 plus 45 is 95% of the area. So we have to find that z value which covers the 95% of the area, because 5% is the fault, is the chance of running short. So this is how you have to find the z value. If it is on the left hand side, it will be less than 50. If it is on the greater than side, then it will be in the range of more than 50 and close to 90, because it will cover the left part of the portion. So we'll see more examples how you can understand or get the z values from the table. This is just to make you understand what is the difference between binomial distribution, Poisson distribution and normal distribution. And normal distribution is a very important concept from our statistical algorithm perspective. And in our next session, we will be talking about different sampling and sampling distributions. So please subscribe, like and comment your channel, and provide your valuable feedback on the comment as well, and stay tuned and stay connected. Thank you.